So at this panel a couple years ago, I introduced this software called Psychbench, and it's probably a pretty different audience this time around. So I thought what I'd do is kind of a retake on that intro, but from a different angle, and also talk about developments from the last couple of years. So this is just going to scratch the surface. It'll be pretty whirlwind, but there's full documentation at psychbench.org, and there's a new tutorial video there as well. So the basics, Psychbench is MATLAB software built on Psych Toolbox. It's free to use and currently a mix of open source and closed source. And it aims to add a high-level layer for building and running experiments to make that faster and easier, while being careful to minimize overhead, retain timing precision, and retain as much of the flexibility as possible. So Psychbench is object-oriented. Each stimulus is represented in MATLAB by an object. Each time you want to listen for response is another object, and so on. Each object has a type or class and has properties depending on its type that you can set for options and parameters. So for example, in MATLAB, we could make an object of type picture using the command picture object. And then we could set a property called file name using dot syntax, or another property called height for its height on screen. And by default, everything is in degrees visual angle, but you can use other units as well. And then maybe some properties start and end to set its timing in the trial. And then we might have another object of type key press to listen for response by keyboard in the trial. Oh, back. And we could set some properties for it too. And there are lots more properties depending on the object type, but typically you only need to set a few to get the effect that you want. And the rest you can omit to leave it default. So the basic idea is that you're working at the level of experiment and stimulus concepts, while the Psych Toolbox level is automated underneath. That being said, there are properties that provide a handle on the technical side if you need, and you can also write custom code, which I'll touch on at the end. So objects are like building blocks. As for how to put them together into an experiment, there are now two ways, and you can choose either one: writing a script in MATLAB or a visual method using tables in any spreadsheet app that you like. So either way, the basic approach is the same. Two basic steps. First, define a set of distinct trials for the experiment by setting the objects for each trial. And by distinct trials, I just mean you can omit any repetition here. You just need to define each distinct trial once, and you can define them in any convenient order. And then two, set a list drawing from those for the experiment to run through. And here's where you would add in any trial repetition and order. So super basic example, let's say we want to do a Stroop experiment where each trial is going to show one of three color words in one of those three actual colors. So we might test these more than once each, but here we would have 9 distinct trials, one for each combination of word and color that we want to test. And if we number those 1 through 9, and if we wanted to run, say, 2 repetitions of each and all in random order, our trial list would look something like this, just a vector, which we could generate with a MATLAB expression. So like I said, there's a script method and a visual method. The script method, just at a glance, this is what our Stroop example might look like with response by keyboard. So we define each trial by setting its objects, in this case, a text object and a key press. And we can use for loops to automate defining our 9 distinct trials, one for each combination of word and color. And then at the bottom, the trial list to run through, and then just the command run experiment to run it. So this is a super basic example, but hopefully it's enough to show the general idea. So the visual method has been the biggest addition in the last couple of years. So here you still work with property names and MATLAB values or expressions, but you lay them out in tables using any spreadsheet app. So here's what the Stroop example would look like done that way. So the approach is the same. We define our 9 distinct trials, here one in each row, and across columns are object property values. Wherever it's just one, that just means the same for every trial in the table. And heading rows, of course, specify the objects and properties being set. And then in this sheet here is the expression setting the trial list, just in a single cell. So what we don't have here are things like for loops and other goodies you could use in MATLAB. But the visual method has options to try to keep things flexible and efficient. So just one example of an option. Rather than write out each of our 9 combinations of word and color like this, we could write just the 3 distinct values in each column. and then put a star here for those columns to tell Psychbench to generate trials for all combinations. So 3 times 3 equals 9 combinations. So this is equivalent to what we had before. Now, this is just an option. We could also spell out the 9 trials for clarity like we had. That'd be fine. I just wanted to show it as an example of the kind of options that are available. And there are lots of other options, and they can be really useful for actual complex experiments, not like this one. So to use this, we would save or export to an Excel file. And then in MATLAB, use the command load experiment to load that. And then once that's in, it's the same as before. So just the command run experiment to run it. And that is the visual method in a nutshell. So I'll just put a few key features up on the screen. These are just some. There's a more complete list on the website. There's also a change log on the website. So if you're interested, you can see the kinds of progress happening over time. And as for object types for stimuli and subject input, currently there are 36 in the library, ranging from basic to pretty niche. All these object types are open source, and there's an API for making new object types. So if a certain kind of stimulus you need isn't in the library, you can write MATLAB plus Psych Toolbox code for it, and then using the API, it will click into your library, and then you can use it anywhere in any experiment, or share it with other people if you want. That being said, I'm always adding to this library, and I want it to have a lot more object types in the future. So I'm very happy to receive requests. That's actually really helpful. And actually fleshing out the library more is something I'll be especially focusing on in the immediate future. And that's it. I'll leave it there. Thanks.